Okay, in question number 11, we're given 4 points, A, B, C, D. And it says, give the most specific name for the quadrilateral that ABCD forms. Include the slope of each side, the length of each side, and any available angle information in the justification for your answer. So I'm being really, really specific here on what I want you to do. But think about this in the future when you do problems like this. These are just kind of things you should investigate on your own. So let's zoom in a little bit and go ahead and plot our points. Our first point A was at 2, 1. Oh, where did you just go? Let's see, here we go. A was at 2, 1, so I'm going to go over 2 and up 1. So there's point A. The next point that we had was 6, 2, so I'm going to go over 6 and up 2. And this is point B. Next, we've got the point 5, 6, over 5 and up 6. Here's the point C. And then finally, our last point D is at 1 and then positive 5. So here is D. So if I go ahead and grab the line tool and connect up these points, I get this. Oh, you get back up there. I get this particular quadrilateral ABCD. And just go ahead and looking at some of the things that the question asks me to find specifically. The first one is, what's the slope of line AB? And you know what, I'm going to grab this erasable tool here. So if I look at AB, and I'll just do this in red, I go up 1 unit and over 1, 2, 3, 4 units. So up 1 over 4, so that has a slope of 1/4. If I look at DC, I can see that goes up 1 and then it goes over 1, 2, 3, and 4. So again, DC has a slope of 1/4. Now that's terrible. I didn't want the erasable pen here. So this was 1/4. This is 1/4. When I look at A to D, that one I go up 1, 2, 3, 4, and then back 1. So that's up 4 divided by 1. So that's -4, right? So my rise is 4, and then I go back 1. 4 divided by -1 is -4. So these both have slopes. Both B, either C. I've got the order all wrong here, don't I? Let's see, AB and DC or CD both had a slope of 1/4. BC had a slope of, let's see, it was 4 over -1, so -4, and this has a slope of -4. So those are the slopes of the 4 sides of this quadrilateral. In terms of lengths, when I look at the lengths, you can see that they all have this right triangle pattern here. It's like 1 and then 1. So if you look at that right triangle, right, it's 1 squared plus 1, 2, 3, 4 squared. 1 squared plus 4 squared. In fact, same thing here. 1 squared plus 4 squared. 1 squared plus, 4 squared plus 1 squared, and 4 squared plus 1 squared. So you can see all of them have they're all right triangles with legs 1 and a leg of 4. So they all have an area that's equal to, and I won't write this every time, but it's equal to the square root of 1 squared plus 4 squared. 4 squared is 16, so they all have a length of root 17. So all 4 of those we just demonstrated have a side length of root 17. So here's what I'm noticing, right? If you look at this, I have these, for example, AB and BC. AB and BC are meeting here at this point. And because these slopes are opposite reciprocals, you can see one's positive and one's negative, and they're reciprocals, I know that this particular angle is very special. It must be a right angle. And in fact, I can see that happening all around here. So if I look at BC and CD, I can see those are opposite reciprocals, meaning this has to be a right angle. And then when I look at DC and DA, let's see, DC and DA, that's a right angle right there. And then the last one's from the last up to the top. One is the slope of -4, and the other one has a slope of 1/4. So I've got 4 right angles, and I have 4 congruent sides. And every single time I see this, right, my grandma always said, if you've got four congruent sides and 4 right angles, what you have there, my friend, is a square, S-Q-U-A-R-E, because it has 4 congruent sides. In fact, they were all exactly the square root of 17 units long, and it has 4 right angles. And if those angles weren't right angles, certainly I could see the opposite slopes are congruent. So definitely it would at least be a parallelogram. But in this case, it's not only a parallelogram, it's a special parallelogram that we call a square.